Okay, hello students. Today we're going to talk about units. So as you can see here on the dollar bill, we have $100 we can recognize very quickly, not just because it's Benjamin Franklin or because we all seen US dollars, but there is something that help us. I'm going to use this kind of screen, make sure you can see the mouse over. But we see dollars, no? $100. So that's what we call units. But in geometry, it's not like currency. We use different units. Why? Because we play with materials, we play with wood, we play with iron, we play with steel, we play with different type of materials. So for example, when you see a scale, you know that you want to weight your own body. So if you want to weight your own body, we need units related to weight, such as grams, milligrams, kilograms. If you want to use liquid, like the Coca-Cola can, it's 33 centiliters or 330 milliliters. That's a unit related to a volume of liquids. Like Isham, the beautiful museum in Qatar, it has a certain shape, which means that it's playing with material. And these material has a certain size. So if we're talking about size, like if we go shopping to Bauhaus, they will ask you how long or how much of this do you want? So if it's a piece of wood, how long do you want that piece of wood to be? So you need different type of units related to length. So these kind of units will be meters, centimeters, millimeters, and so on. So before doing some exercises, let's minimize that and let's try to answer the different questions that we tried this afternoon. So when we think about units in math, the units will be, I'll say all that orally because I got a little problem. Yeah, I'll say it orally, guys, sorry about that. What is a unit in math? It's something that we like using after a number. So in this case, it's going to be standard of measurement adopted by mathematicians. So standard of measurement, that could be meters, kilometers, kilograms, and it's adopted by mathematicians because it's related to the 3 dimensions. It could be related to length, it could be related to width, it could be related to depth, it could be related to quantity of liquid, it's related to math. So standard of measurements. We always write that unit after a number. Why do humans want to use units in their daily life? It makes our life so much easier, no? Think about it. I want to go and buy some oranges, or I want to go and buy some fruit. If we say I want 2, I want 5, and I want 6, you may ask, what are you talking about? So we need a unit, we need a word after numbers. If I say I want to go and buy 2 oranges, 3 pears, and 2 watermelons, you will suddenly understand what I mean. If I say, hey, wait a second, I want 2 of this, what do you mean? I want 2 meters of that piece of wood. You suddenly understand what am I talking about. It gives a certain dimension to my to the meaning of my sentence. So if we focus only on units related to length, we have plenty of different units. The most famous one that I want you to remember, I'm gonna edit a copy, it's gonna be easier for you. Hectometers, so kilometers, hectometers, decameters, meters, decimeters, centimeters, and millimeters. Fill this up. So we have in this case, I want you to know 7 different units related to length. Okay, so when you measure something, you need with your ruler to measure in centimeters. If you want to be more precise, it's going to be in millimeters. If it's getting bigger and bigger and bigger, to avoid using too many huge numbers, we change the unit. So let's focus again on these units. Currency, try to think about 3 types of currency. Quantity of liquid, think about 3 types of units related to quantity of liquid. I help you with 1. Milliliters, think about the rest. Check on the internet if you want to know. Weight of object, I helped you with 1. Kilograms, think about 2 others. Currency, I'm going to help you. US dollars, think about some others. Currency is not really related to geometry except if we transform that into a graph, but doesn't matter. Volume and 3D shapes, centimeter cubic, and try to think about 2 others. And area, squared, centimeter squared, think about some others. Okay? Now, the problem is that, imagine I go to Bauhaus, I bought some piece of wood, and I'm asking 100 millimeters of wood. And the guys are like, what are you talking about? Here we measure everything in meters. I'm like, oh no. So what should I do? I should, what we call in geometry, transform your unit into another. So when we look at the scale here at the top, we have to know how to move from one to another. So let me minimize that and let's focus on an example. So here I get my scale. Oh, I'm missing some. So let's try, oh, hello, Mr. Sam. Let's try to fill this up. As you can see, it's completely wrong. Let's see if you remember. Let's start from the right. We get millimeters. That should be centimeters. Very important to remember that, okay? That's going to be the most important scale of the year. Better if you memorize it, or at least have it in front of you written on a piece of paper for the exercises that you'll need to do today and on Friday, okay? So me, it took maybe years, but I know it by memory. So better if you can do that too. So imagine I need to transform kilometers into meters. How do I do it? Now I know in primary they said when you jump from one unit to another and multiply by 10, divide by 10, divide by a million, divide. Don't do that. Don't do that. I don't know why they do teach this. Make it simpler. Why? Because look, you told me you want to transform that 3 kilometers into meters. So 3 in algebra is actually 3,0. It's the same, okay? So we have a little comma here. So if I have another number, imagine not 3 kilometers, but 65 kilometers, my number is 65,0. Means exactly the same. But I want you to really see that comma. And when we move from one unit to another, the only thing we need to do, it's moving that comma to the left or to the right. So here, when we look at our scale, we go from kilometers to meters. Kilometers to meters. So let me color that into a nice, beautiful color. Oh, wait, I'm stressing. Oh, Mr. Sam, wait. There we go. So imagine we go from kilometers to meters. What are we doing with our eyes? We're doing 1, 2, 3 jumps. No? 1 jump, 2 jump, 3 jump. So what do I need to do with my comma? I need to move it 3 times, but to the left or to the right? What am I moving my mouse? Am I moving my mouse to the left or to the right? To the right. So the only thing I need to do with my comma, it's moving it 1 jump, 2 jump, and 3 jump. So when we compare my comma at the beginning, which is here, what I did with my comma is moving in the same amount of jumps. So 1 jump, 2 jump, and 3 jump. So you can see my new comma here is 3 numbers to the right. Because there was nothing here in between, I had to add some zeros. So at the end, my answer is 65,000, meters. Now, should we write at comma 0? No, everybody knows that it means 65,000. So if we do another exercise just below and make it a little bit more complex, let's say 8,75 kilometers. Now let's try to do meters into millimeters or centimeters to change the amount of jumps. So what do? I like rewriting my number. I already have the comma. Perfect. And I'm looking to go from meters to centimeters. So how many jump is that? Let's see. Let's recolor Mr. Sam. There we go. So let's recolor meters and centimeters. There we go. So how many jumps do we have? 1 jump, 2 jump to the right. So what do I do with my comma? I'm going to move it 2 jump to the right. So imagine that little comma to be a kangaroo and 1 jump, 2 jump. So it's here now. So I erase my first comma, which was at the beginning, and now it's 875,0. Do I need to write that comma 0? No, it's a natural number, so we can just write 875. To do one more exercise, let's use a complex number. In this case, I'm going to move to hectometers. So I use the same number, but instead of going from meter to centimeter, I'm going to go from meter to hectometer. So let's visualize that. 1 jump, 2 jump. So we go 2 to the left. So I'm moving my comma 2 times to the left. So I like starting with my initial comma, 8,75, but I need to move this comma like a kangaroo twice to the left. So that would be once, and I would need another comma. So it's a bit of a mess. So what do? I add some zeros. So imagine I'm adding a lot of zeros. Where do I need to stop? So my comma start here, but I need to move it twice to the left. Where does it stop? Jumping over here. I erase my initial comma. Do I need to have so many zeros here up front? 0,0875 hectometers. So as you can see, that's my technique. We're not playing with millions. We're not playing with multiply by 10, divide by 10. I really don't like that. I like a visual, which is having the scale and finding out, like a kangaroo, how many jumps that comma needs to do to the left or to the right, and the empty space is filled with zeros. So let's do one more. Let's try to do it with an easy number. I don't want you to get too crazy. Let's do millimeters to kilometers. Oh, we're going from the left. What's wrong with my computer? There we go. No. When you do it well. There we go. There we go. So we're going from meters, millimeters to kilometers. So I'm going to color that same way, like it's easier for you. Wow, I'm doing a lot of jumps. 1 jump, 2 jump, 3 jump, 4 jump, 5 jump, 6 jump to the left. So I'm going to start with my initial number, being 5. No. My comma, where is it right now? It's 5, 0. It means the same in algebra. You should know that from primary. And I want to move my little kangaroo comma. How many again? 6 times to the left. And I know that the space that I'm going to have between these jumps is going to be filled with 0. So I like filling this with a lot of 0. I'm on a computer. It's super easy. And let's see, where should I place that little comma? 1 jump, 2 jump, 3 jump, 4 jump, 5 jump, 6 jump. And I erase all the one that bothers me that too much. So I like checking again. So we had to move from here to there. I don't need that comma anymore here. So I started there. 1, 2, 3, 4, 5, 6. Perfect. It's in the perfect position. I just missed the unit. That's it, guys, for today. What I would like you to do to find out if you understood it before sending you the answer on Friday is do the exercise 6. So 0,156 centimeter into hectometers and so on. Better if you have the scale in front of you. Thank you very much. Bye-bye.